So hello everybody. So first let us introduce ourselves. This is Sanja Bonic and my name is Bartholomaeus Wloka, or short Bart Wloka. We're both from the University of Vienna. So we have both of us have a computer science background. Sanja has experience in teaching various high school grades. I teach at the University of Vienna computer science classes and computer didactics classes. And we would like to present to you our idea of tangible mind mapping and analytical thinking methods. So analytical thinking methods is something you can, it's something that's quite clear, but what are tangible mind maps? We'll go into that in a minute, but at first let us tell you about the status quo, what's happening at the moment in the educational system in Austria, especially in Vienna. But also in most of the countries in Europe, and as we heard before in the keynote speech, also in the US. So there is a low media literacy. It's the low media literacy is found in lower grades in high school, but it's also found amongst teachers. It's found amongst even university professors. So that's a problem definitely that needs to be addressed. There is a low interactivity in the classroom instruction. It's in high school, as well in high school as also in the university setting. There is a low interactivity. It's a one-sided teaching process. It's a process of outside in. Basically, the teacher is giving the lecture, is teaching the students, but there is no interactivity going on. So the teacher education, that's also a reason for that, is that the teacher education itself is very theoretical, especially in Austria, especially in Vienna. Very theoretical, so the teacher is not very well prepared for his task of creating the teaching materials. And it's very strictly textbook based. That's one of the reasons also because, since it's so theoretical. Of course, so our goals, what we would like to do is to, of course, improve this improve the media literacy. So how do we do that? We live in an information age. We have a lot of information, we have a lot of data around. Data is not information. We have to make sense out of data to get information out of it. So this is the first step. This is the identification of data. What do we need in order to create something that we want to do, right? So what do we need? We need to identify the data we need. So once we have identified the data, we need to extract it. We need to extract the right amount of data to make it information, to make it meaningful. Once we have extracted this data, we have to analyze it. We have to make sense out of it. What does it mean? What is the information? How can we combine? How can we correlate information? How can we compare information to come up with a meaningful result? So the next thing we would like to address is the interactivity in the teaching process in the classroom. So the interactivity includes making associations according to prior knowledge, very important, and creating presentations. This goes into a more creative kind of setting, creating presentations, creating stories, creating games. We had in a previous presentation, in a previous breakout session, we had that example of writing, of promoting writing, a very important thing to let the student and the pupil get creative, create something, make this process inside out, this teaching, this learning process. So the next goal is to reform this educational system. This educational system right now lacks these things we mentioned before. So how do we reform this system? So this has to happen, of course, gradually. As every reform, it's very hard to do, of course. It has to happen from the very first grade and continue therefore, but also the later grades have to be reformed. So both teachers and students are involved in this change, in this reform. And a very important point is the equipment and the didactic methods we use, and this is what we focus on in our idea. So here we come back to the idea of tangible mind maps. So what are tangible mind maps? Tangible mind maps are basically gadgets that the child or student gets into his hands. So these gadgets, they vary in size, structure, material, and amount of information they contain. They're suitable for every object, and they can be combined with technology. So this is a rough idea of what a tangible mind map is. So now let's get an example, because it's still hard to imagine what it is, I guess, for you. So here's an example of a tangible mind map regarding to geography. So we have a wooden map of the US. So let's say this is a wooden map about this size, is a couple inches thick, and we have this wooden map, and this wooden map consists out of puzzles pieces, and these puzzle pieces are the states of the United States. So we have every puzzle piece, every state is a tangible mind map. So once the child pulls out a piece, a state, this tangible mind map, can flip it open, and it's sort of like a Swiss Army knife where you can pull out these pieces out of it. And these pieces contain the keywords that are associated with this particular state, with this particular US state. So if we pull out, for example, Utah, we maybe get mountains as a keyword because they're mountains, so this is a very characteristic for the state. So we have the keyword mountains. In the back of it, we have additional information, like the student or a child can flip it around, there's more information about the mountains in Utah. So these are the most important facts. We call it vertices in this case. This information that is contained in the tangible mind maps. So we have this information, the very basic keywords, and more information in the back, which facilitates the memorization process. It helps the child to memorize it better. We have the kinesthetic learner type is favored in this approach because it's a hands-on. They take this puzzle piece out, they fold it open, they see this is the keyword. Here we have as an example a bumpy texture to indicate the topology of the state Utah. It's mountain, right? They're mountains. So this puzzle piece is bumpy. So there's the first impression. Okay, that's a state that has mountains. So another example. In regards to vocabulary, of tangible mind maps regarding vocabulary, could be, you could have concrete or abstract models. For example, a concrete model would be, for example, a house. We have a house, we could have physical, the physical representation of a house. We have this building up there, and we can just like before with that state example, take things out, and we have these concepts like furniture, appliances, and rooms, and it could stretch over several levels depending on how this tangible mind map is designed. So we can have furniture, and we can have chair, we can have everything that's coming out of it. So depending on how many levels we have.
This is especially good for foreign language learning. For example, if you have the physical representation of a house and it says house, you don't need the native word for it because the children know what a house is, so they will just have, for example, an English house, then they pull out furniture and they pull out a chair. Those things are still attached, every element is attached, so if you pull it out like in a Swiss Army knife, and so you would have the image of a chair and it would say chair. So this is better to memorize vocabulary.
Exactly. It's not the process of going from one word to another like in a textbook, but it's by association. It's by a picture. The student sees a house and he sees the word, and he doesn't need for example, the German word. If he's going from German to English, he doesn't need the German word of house. He already sees it's a house, and the learning process is more intuitive. So. Similar to that is the abstract approach, where we have some abstract word, like for example agreement. We have the tangible mind map of agreement, and the student, the child, takes out pieces that give him the affirmative answers like yes and sure and of course, and so it's also there's the concept of connection of concepts of even abstract concepts.
And for every word you have the pronunciation. So you push a button and you hear the word. It's especially good for foreign language learning. This is the combination with technology then.
Exactly. It's something we have seen also in the keynote speech where we were presented different iPad apps where you have on the push of a button you get the pronunciation, of course, reading an ebook and stuff like that. So this is similar, but in a more hands-on setting, basically. So this way, of course, the child can improve his or her vocabulary. We have the pronunciation, and we can combine all of this with collaborative tasks. Like, for example, we call the forbidden word task. Once the child has learned with this tangible mind map, and the child has studied different words, synonyms for a different word, or different affirmations that we have here as an example, there could be a task of writing a dialogue without using certain words. or without using certain words. So we have the forbidden word task, and this will promote the application of this concept right away into task, into a dialogue that has to be written.
So, for example, they should write a dialogue about how they went shopping with their parents, and every answer should be something positive, something in agreement. But they mustn't use the word yes. And so they have to use certainly, of course, sure, and all the words they've just learned from the mind map. Else it's just a toy. The mind map is just a toy if it doesn't come in combination with tasks and detailed learning.
So again, the question, why tangible mind maps? Why should we do that? Again, it's basically explanation of why we want to integrate this concept into schools. Is they have to understand the general concept. Obviously, when you take us, coming again to this example of puzzle pieces of the Utah state as a puzzle piece, and taking out and seeing the concepts of mountains and other stuff, other things associated with the state in particular. They allow associations in accordance with prior knowledge, with individual knowledge. The child can associate freely what they have known before, what they have learned out of the tangible mind map. It promotes the learning, the kinesthetic learning, which is not very well done at the moment, because the children most of the time are sitting in a classroom setting, and they're not doing anything associated with learning with their hands, with anything physically. So this will be a promotion of the kinesthetic learner type.
In biology, for example, you would have mind maps with flowers. I mean, you can just have these stripes with a certain smell, and you could also incorporate that in a mind map. For example, the children are learning about flowers, and okay, they pull out the rose from a certain flower, I don't know, certain flower species or so. They're pulling out the rose and they're smelling a rose, for example. So
you can address maybe more senses of the physical, even the smelling in this example. The structure of this information as a tangible mind map facilitates the memorization. It makes it easier to memorize, because you have the associated with what you have in your hands, with the hands-on experience. What you see, you can actually fold it up and look at it, so that facilitates the memorization process, makes it easier. Eventually, creating mind maps will also be possible for the children. So creating the concepts of, once they have learned a couple concepts, they've seen a couple examples, they can create their own concepts. Maybe take something they know and they come up with things that are associated with it. So this is the creativity involved. The creativity is also involved in the process. The multimodality, of course, as we just mentioned, with the smell, the touching, this particular tangible mind map, and the constructivism approach, especially in combination with the creativity.
Okay, mind maps especially cater to meaningful learning. There's a technical report. You can see the exact citation there, and you'll have it on the slides then. And in that technical report, they mention 3 most important points why concept maps are so good for meaningful learning. The first is the material to be learned must be conceptually clear and presented with language and examples relatable to the learner's prior knowledge. So if we have children at example age 4, 5, 6, and they are learning about the furniture in the house, they would know the language and examples, and they can relate to it, and that's very important, of course. Second important point is the learner must possess relevant prior knowledge. It correlates with the first point, of course. This condition can be met after age 3 for virtually any domain of subject matter, but it is necessary to be careful and explicit in building concept frameworks if one hopes to present detailed specific knowledge in any field in subsequent lessons. That means that if a teacher is going to present more details, is going to go into more detail, okay, he or she has to address the graphical map, of course, because else the children have seen the mind map or the concept map, and they can't relate to what the teacher says, because it's something completely different. So the teacher has to combine this with the things. And the learner must choose to learn meaningfully. I won't read it out because we only have 5 more minutes. So the motivation is very important. And in the tests right now, they aren't really self-motivated. It's just a repeat and learn by heart. And the most important thing is, with mind maps, they use their own words. Of course, they can't recall everything what the teacher said in exactly the words, but they know what he said or she said. Sorry, and they understand the general concept, and that's what's more important. Other features of the tangible mind maps are it's a new form of indexing, and that's the future. It's the semantic web. And if they learn it in early childhood, if they learn about the concept in early childhood, they can use search engines better and understand the concept of the semantic web. So we have to incorporate didactic methods, as we said, with the collaborative tasks and everything. The teacher has to present its subjects in form of graphical maps, has to relate to the mind maps. And afterwards, for example, if a child knows about the concept, for example, the house, he or she could make a mind map of his own, for example, in art class, and then present it. Collaborative task, for example, could be a child has learned something through a mind map. For example, one child had Utah, learned about Utah, and then has to present it, and the other child has to repeat what the other one presented. And another good application, we had it before, the videos, but Scratch is another nice tool. So Movie Maker, of course, is great, and Scratch is an authoring tool. This is a description of what Scratch is. It's developed by the MIT, and you can tell stories, develop animations and games with it, and you learn the basic principles of programming. Here's the stage. Here you can, for example, if children have drawn something in art class, they can scan it and import it here, and they can make a whole story out of it. With these buttons, you drag them here and say, for example, take this part and move it. So they could make a moving cat or really tell a story with their own pictures. Okay, last 2 slides.
Okay, so we have... as we have previously seen also in keynote speeches, we have this taxonomy of learning and teaching and assessing by Anderson and Cartwell. Here we have it again. On this axis you have remember, understand, apply, analyze, and evaluate and create in this order to this side. And here we have the knowledge, factual, conceptual, procedural, and metacognitive. So we have this biaxial graph. Where we have these 2 concepts, and the tangible mind maps fit somewhere in here on the right upper corner, because we have, by dealing with tangible mind maps, the remembering process is of course promoted, the understanding process is promoted because the concepts correlate, the application, because the children apply the previous knowledge to whatever they see in the tangible mind maps. They analyze the context, they evaluate, and finally they create, as we've seen before, making mind maps themselves or creating programs in Scratch, a very simple way of learning programming and being creative with computers. So we have this process all the way up in the upper right corner, which is most of the time the goal. So to conclude, we have addressed the problem of the one-sided classroom instruction, because now the children have hands-on experience. They have this tangible mind map. They can open it up. They can see what are the things associated with that particular piece, with that particular concept. They can ask the teacher further questions. So it becomes a very interactive setting. So the didactic methods, like the presentation we had mentioned before, and creative process with Scratch, helps to improve the media literacy and enable associations with prior knowledge. And it of course helps in the early childhood, the tangible mind maps in the early childhood help to prepare for this constructivist learning approaches, which should be further carried into later education and into high school and into university as well. So thank you very much.
I was curious about how Scratch works with this, like how the kids actually create the tangible mind map idea within Scratch.
For example, they have created a mind map, so they have certain ideas. They got to know other ideas because they of course exchanged the ideas and they exchanged the mind maps they have created themselves, or they have used a mind map to learn, and they could develop a story around the whole mind map. For example, they have, I don't know, a house mind map or biology, and they have to create a whole story around it. Or they could create the mind map either in art class or in Scratch, for example, where they can pull out things in virtually. So they could either create a mind map in Scratch or make a story out of the concept. It's just so they learn the basic principles of programming combined with getting to know a concept. So it's
especially the great thing about Scratch is that it makes this creative process very easy, because you have over here on this left side, this is a typical screenshot of the whole developing environment, and here on the left side you can see the very basic actions you can perform. Here you can see the actual program. It's a drag and drop process to create this program, and on the right side you can see your result right away. So it's an on the fly. As you build a program, you can see your result. You can see right here. You can see a cat walking along the screen, and you can tell you can make the cat make 10 steps, and if it takes 10 steps, it does this and that, and it scratches itself or whatever. So you can incorporate this very basic building blocks of building a computer program in a very easy manner. So you can prepare children, prepare kids to deal with computers, to deal with computer programs, to deal with algorithms, with procedures that they're definitely gonna need.
They're learning a structure and organization from a mind map, and they should be able to apply it to something else
into the program. Are there any more questions, please?
What ages have you used Scratch for?
What ages? I had a professor myself when I did computer science education, and she worked with from 9 to 99. So they had courses with grandparents and children who came together and learned basic principles of programming, and it worked really nice. And we did it in a few classes as well. So I did it with 15 to 16-year-olds.
Okay. I have daughters who use it in kind of 4th, 5th, 6th grade. So
Okay.
I haven't heard about it below that yet, but kind of 9 is about the right age.
Yeah.
I've heard as well.
Is it how do you get that program?
It's freeware actually, and you get it from this homepage, scratch.mit.edu. So it's developed by MIT or maintained by MIT. You can get it for free. There's also a gallery of loads of games, animations, music. So
there's a lot of demo material, examples you can look at, and it makes it starting developing this program really easy.
There are other authoring tools as well, like Alice, or the more advanced ones like Open Wonderland, and there's a whole initiative, immersive education initiative, that goes much into virtual education and virtual reality. But Scratch is a really basic, very basic tool for more for children, more suitable for children.
Do you have any pictures of your mind maps? What your mind map, examples of it, other than
We wanted to build a prototype actually, but we didn't have the funds, so
we're not.
We're
lacking funding at the moment, so
Yeah.
it's just at the first the concept at this stage.
Yeah. So we're looking for sponsors if you know anyone.
Please.
Which tools are you using for creating the mind maps? Is it, for example, CMOP tools?
You mean to physically create it? Is that what you're talking about? Well, we haven't had any. We have ideas, but we don't have any practical implementations yet. So, like we said, we're lacking at the moment the funds to practically implement this concept. So that's the stuff we're still thinking about it at the moment.
Yes, so these are not digital mind maps.
No.
They can be. They can be. They're very much physical. They're very much physical. So we want to address the kinesthetic learning type. We want to give children hands-on basically, so they can really physically open up the mind maps and get them in their hands. And it very much depends on what it's gonna be, on how they're gonna be made, right? So
this should be really for when they're attending school, and the rest can be interactively and virtually. That's what we are developing, or we're trying to develop right now, is the virtual representation of that, and then you can go into deeper levels. For example, you have house furniture, and then you would go deeper and deeper and deeper, and you could have a network and you connect to each other. That's of course not possible with the physical representation, but you get the general concept, and then you move on to the computer.
And have you heard of CMAP tools? Because you have mentioned Wloka and Sanja, and they have developed it, and it's free on the internet.
Okay.
And you can also use it in real time collaboratively to create these concept maps, and you can attach files, pictures, video to each node in this concept.
Ah, okay, that's great. Yeah,
We'll look into that.
there are a few mind map tools around, but yeah, that's yeah. Thank you. Okay, well, thank you.